All right, get your name on this packet. I am going to give you some pointers on some of these before I let you work individually and independently on this. So make sure you're following along. If you need to pause the video at any point, go ahead and do that. But make sure your name is up here at the top. Okay. Now, on these first ones, these are pretty much straightforward. I'm going to have you write no calc next to that one. That's probably the type of question that would show up as one of your 5 where you can't use a calculator. Okay. This one may be a no calculator one. So when it comes time to do it, see if you can try to do it without using a calculator. Okay. Same thing, no calc for 4, 5, 6, and 7. When you get to 8, then we're going to use a calculator. On question number 8, here's what I just want to remind you, because this goes back to about, I think, Mod 6 when we were doing all of our percent stuff. They give you the interest formula here, and feel free to go ahead and write it in here. Remember, P was the principal amount of money, so this is a money amount. This is the percentage rate. This is the time in years, and then the interest will also be a money amount. So when you calculate that out using a calculator, just make sure you're plugging things in the right spot. All right, turn the page, because on the next page, I want to make sure, I think you can figure those out. I want to talk about number 12. So find problem number 12. It's been a while since we talked about proportional relationships. We did this, I think, gosh, back in Mod 5, so it's been a while. And here's what I'm just going to tell you. I'm not going to give you the answer, but I am going to tell you this. A proportional graph, so write down the word graph, it always goes through the origin, because we just have some kind of multiplier, all right? So as long as you have that written down, you probably can already determine what that answer is. Now I want you to turn, because we have to look at both question number 13 and number 14, okay? Because we're still talking about proportional. When it says what represents a proportional relationship, grab your pencil and I want you to write this next to it. Y equals K times X. If you remember seeing this, usually we had a table like you see here, and you tried to figure out what is this constant, that K, that we always multiply by. So pretend, for example, that we had a table and whatever we get, that K value, the constant is always 5, okay? So if I had a table, it might look like this. 0 for X would be 5 times 0, that's 0. If I put in a 1 for X, 5 times 1 would give me 5. A 2 for X would give me 10, and so on, okay? Now, sometimes I might tell you, as you were looking at this, if we didn't know what the multiplier was, I'd often tell you to take whatever your Y value was, divided by your X value, and that should give you your constant K, this magic multiplying number. And so here, you can't use 0, 0, because you can't divide by 0, but 5 divided by 1, or 10 divided by 2, that would give you that value. Now, this is the format you usually see a proportional relationship in, but I don't see, first of all, I don't see Y's and X's. It looks like they're using R's and T's. So on this one, it looks to me like I should see something like R equals some number times T, like this, and it doesn't look like A. This one says R times T is a number. No, that's not it. C doesn't even have the second variable in it. And so when I look at this, I'm like, Well, that's the one that's left, but it doesn't look like it's in this format. And I'm going to tell you, aha, but it is kind of in this format where they're saying that some constant number is what I get when I divide my two variables. And there you go. So choose D, and we'll practice more with those as we get closer and closer to your MCAs. All right. Let's also do 14 together. Sometimes you can just see what is the number that I multiply my x value by to get y. How do I multiply? And 0, 0 isn't going to help you because any number in the world gives you this. But when I look at this one, what can you take 9, multiply it by, and end up with 3 as an answer? I'm like, ooh, it's getting smaller. Whoa. So it looks like I have to do something like, if I divide both sides by 9, it looks like my constant is actually the fraction 1/3. I take 1/3 times 9, I get 3. 1/3 times 18, I get 6. 1/3 times 27, I get 9. Now, as I'm looking at this, it's like, that means I should have an equation that looks like this. Y equals 1/3 times x. So I'm looking at my choices. Y equals 1 times x? No. Y equals 3 times x? No. I'm not taking my x number, multiplying it by 3 to get that. That's not it. X and y are not equal to each other. Okay, this looks weird. Oh, they flip-flop the x and y around? Really? If I multiply both sides by 3 on this equation, I would get 3 times the y value gives you your x value. That one was a tricky question because it was a little backwards in how it was written. So that's why I wanted to make sure that we talked about that one. All right, 15, 16, I think those ones on the rest of this page should be okay. Please turn to the next page. 17 and 18 are percent ones. I think you can figure that out. When it's multiple choice, sometimes just try those and go from there. 19 and 20 would probably be a kind of question that they would say no calculator on it. So see if you can figure out and evaluate what these expressions are equal to when you have to substitute. Same with 21, okay? Same with, well, that one's algebraic because you still have a variable there. So maybe not. I will say this, remember how to use the distributive property. 3 times parentheses, you got a bunch of stuff. That means 3 times 4, that's 12. And then minus 3 times this 1t. This is like 3 times -1. That's -3t. Okay. Then continue on. Minus, see if you can calculate what 13 times, this is 25 is. I think that's 325. And then last but not least, this is one expression, and you always have to divide before you add and subtract. 8t divided by 2, 8 times t divided by 2, that would simplify to be a 4. So this is really plus 4t. Now, you're not done yet, but see if you can take it from this point to figure out which one of those answers is correct. Okie doke. Awesome. Turn the page. All right, 22, 23, 24. I think you can work your way through all of those. On number 25, see if you can figure this one out and see if it would make sense. It's a little more complicated, and we'll talk about this one on Monday. All right, keep going, keep going. Hey, when you get to the next page, here's some of this geometry stuff that we just did. Okay, if you have your formula sheet, you can use that as a guide. But remember, circumference is pi times diameter. Volume, the formula looks like this, capital B times H. Capital B means what is the area of the base. And if it's a cylinder, that means the base is a circle. And so just this part is area of a circle, pi r squared times H. So now see if you can figure this out. This is giving you a value for the volume, means you're going to have to put the 88 in here and then see if you can work backwards to figure out which one of these is the most accurate radius. 29. The height of a cylinder is the same as the radius. Which expression represents the surface area? Oh my gosh, they don't even give you any numbers. Crazy. When we had a cylinder and I was asking you to find the surface area, we broke it down like this: top, bottom, and all the sides. So you have a circle for the top, you have another circle for the bottom, and then that side is a rectangle. And hopefully this will stay fresh in your head. Pi r squared for one circle, pi r squared for this circle, and the area of this rectangle is pi times diameter times height. What they're telling you is that the height is the same as the radius, okay? The height is the same as the radius. So instead of having an h, you could turn that into just another r. And diameter is always 2 times r. See if you can figure out which one of these matches up. That one's going to be a good challenge for you. As far as the rest of it, I'm going to have you now go ahead and turn to find question number 34. So we've got to go forward a few pages. It's right here. I don't know if you've seen stem and leaf plots like you did, if you did in 6th grade or not. We actually, in the next week or two, are going to start working with some data and mean, median, mode stuff. But just so that you can tackle these, because this should happen or kind of come back to you pretty easily because you did this a lot in 6th grade. A stem and leaf plot is a way to organize a whole list of numbers. And here's what it means. These digits are in the tens place, and these digits are in the ones place. So here's what it looks like. In the 4 row, this really stands for the 40s. And that means I have 1, 2, 3, 4. I have 5 numbers in the 40s. They happen to be 48. I have another 48. And then I have 49, 49, 49. In this row that starts with 5, this is your 50s row. And this means you have a 53, a 57, another 57, a 58, and then 2 59s, and so on. So when you have this whole data list, then you should be able to find the mean. Then you should be able to find the median, and likewise answer that question as number 36. Okay. All right. As far as the rest of these pages, look them over. We will still review some of the graphing things and some probability. I want you to make your best attempt at answering these questions. Okay. All right, I'm going to bring this back to the very beginning on this page. Again, please make sure your name is up here on the top. Yes, make sure you go ahead and grab a calculator. There are a few of these that I'm saying try to do those without a calculator. And use the rest of the hour to work on this so that you can get it all done and you won't have homework over the weekend. All right. Good luck, and may the force be with you.